I chose prompt 1 for this genetic video. This is the original coding DNA strand from 5' to 3'. Through transcription, it will produce the following mRNA. Translation occurs from 5' to 3' end of mRNA. Each codon is made up of 3 nucleic acids. Each codon translates a specific amino acid. The following mRNA creates the amino acid sequence in this order: methionine, valine, arginine, phenylalanine, lysine, and the UAA signals the stop of translation. Point mutation is a change in one nucleic acid. One type of point mutation is missense. Missense occurs when a point mutation causes translation of another amino acid. For example, in this DNA coding strand, this G is mutated to a T. When transcription occurs, the G in the original mRNA will become a U, which will replace the arginine with serine. If the change in nucleic acid is from purine to purine, then it is a transition, and the same with pyrimidine to pyrimidine. However, if it's from purine to pyrimidine and vice versa, then it is a transversion. In this example, the mutation is from purine to pyrimidine, which is a transversion mutation. Another mutation that can occur is nonsense mutation. This is where translation stops earlier than it is supposed to. For example, this A in the DNA coding strand is changed to a T. When transcription occurs, the A in the original mRNA will become a U, which will signal a stop after phenylalanine. This amino acid sequence will be comprised of 4 amino acids instead of the original 5. Since mutation in the DNA is A to T, then it is a transversion mutation because A is purine while T is pyrimidine. Another mutation that can occur is silent mutations. Silent mutations when a change in a nucleic acid still translates into the same amino acid. For example, the G in the DNA coding strand is mutated to an A. The G in the original mRNA is changed to an A when transcription is complete. Since this is a change in the third codon, it will affect the arginine amino acid. The mutation in the coding DNA strand still produces a codon in the mRNA that translates to arginine. Although the DNA and mRNA are not the same as the original, it still produces the same amino acid sequence as the originals. Mutations from G to A in DNA is transition, since G is purine and so is A. Read-through mutations when a nucleic acid in the stop codon is changed to produce amino acid. For example, the A is changed to a C in the DNA. In the mRNA, instead of the original stop codon UAA, it becomes UAC, which translates into tyrosine. This changed the 5 amino acid sequence into a sequence containing more than 5 amino acids. The mutation from A to C is transversion mutation.